Hello! Today we are learning about adding and subtracting rational expressions. And before we get to the crazy stuff, I just kind of want to take you down memory lane and show you how to add fractions the good old-fashioned way. You remember, maybe you don't, so I shouldn't say that, but I will remind you that when you are adding two fractions that have different denominators, one of the first things you want to do is to find a common denominator. And the way that you can do that is by looking for what they call the least common multiple. So the first thing we want to do is take the factors of 15 and the prime factorization of 9. And the prime factorization of 15 is 3 times 5, both of those numbers being prime, so that's factored. And the prime factorization of 9 is 3 times 3, or basically 3 squared. Now the rule of thumb is that when you're looking for the least common multiple, you have to take every factor that is represented between the two. So in other words, they have 3, 5, and 3. So the two factors are 3 and 5. In addition to that, you have to take the highest exponent of any given factor. So since this has a 3, but this has a 3 squared, you take the higher of the two and you get 3 squared. So the least common multiple is 3 squared times 5, which is 9 times 5, which is 45. Again, most of you probably already knew that without doing all that work, but when we get to rational expressions, you're going to have to be able to do that, so I want to make sure that you know how. Okay, so what do you do with the least common multiple? We know that eventually the denominator is going to be 45, and so the idea is that you have to multiply this fraction by what it's missing. So this fraction has a 3 and a 5, so it's missing another 3. So you multiply by 3 over 3. And this guy is missing a 5, so you multiply it by 5 over 5. And then you get 3 times 2 is 6, so you get 6 over 45, plus 1 times 5 is 5 over 45. And in the end, the answer is 11 over 45. And that is how you add fractions. So in a sense, that's kind of what we're going to be doing in today's lesson, only we're going to be doing it with polynomials and crazy rational expressions. So the first thing I want to do is we're going to try to find the least common multiple, just like we did in the previous example. So in this case, the first factor is 4x squared minus 36, and the other one is 6x squared plus 36x plus 54. And the first thing we can tell about these two terms is that they both have, so basically we have to factor it. So they both have a 4 in common. So I take the 4 out and I get x squared minus 9. And then this is still a difference of 2 squares, x squared minus 3 squared. So that you get the final factorization as x minus 3 and x plus 3. Awesome. Now for the bottom, I'm pretty sure that they all are divisible by 3. So let's see here if I can, or by 6 even. So I can get out a 6. And if I factor out a 6, I'll get x squared plus 6x plus 9. All right? And that will give me that little guy. And then I can still factor this guy out with the little plus. You could do 1, 1, 3 times 3 is 9, 3 plus 3 is 6. So you'll get 6 times x plus 3 squared. They're both x plus 3. And you could even further, prime factorization of 4 is 2 squared times x minus 3, x plus 3. And the prime factorization of 6 is 2 times 3, and then the x plus 3 squared. So you will remember that I said earlier that in order to find the least common multiple, you have to take every factor that is represented. So we have a 2, we have a 3, okay, so we got a 2 from here, and a 3 from here, an x minus 3, and an x plus 3. Those are all of the factors that are represented in these two factors, or in these two expressions. So then the next step is that you have to have the highest exponent of any of those factors. So this has a 2, but this has a 2 squared, so we need a 2 squared here. And then as far as a 3, there's only one 3, so we're good with that one. X minus 3, there's only one x minus 3. But for the x plus 3, this one is x plus 3 squared, so we need to have x plus 3 squared. And in the end, the least common multiple will be 2 squared, which is 4, times 3 is 12, x minus 3 times x plus 3 squared. This is the least common multiple between these two expressions. All right, so now I'm going to want you guys to try to find the least common multiple of these two pairs of expressions. And just for Ben, I want to be clear, that's a 6x plus 30, all right? And that is a b, so yeah. Okay, so now, obviously being able to find the least common multiple is important because it's how we actually add fractions together. So in this case, we're going to do an addition problem where I'm taking these two fractions I want to add together. So obviously the first thing I begin with is I need to find a common denominator. So to do that, the very first thing I want to do is factor. So I'm going to take the x squared plus 5x plus 4, and we're going to factor it. So 4 times 1, and then 4 plus 1 is 5. So my two factors will be x plus 4 and x plus 1. And then I want to take the other expression, the 3x plus 3, and I also want to factor that, and they both have a 3 in common. So the 3 comes out, and I get x plus 1. All right, so the least common multiple between the two expressions is going to be a 3 and an x plus 1. They both have an x plus 1 and the x plus 4. None of these factors have any squares or cubes or anything. So that's pretty much my common denominator, my least common multiple. So I know now that the common denominator is 3, x plus 1, and x plus 4. Now if at this point you're kind of scared, I just want to remind you again of what we did at the very beginning. You have to find the least common multiple, which is 45. And that becomes the common denominator here. But now I have to go back and multiply my original fractions by whatever it's missing to get to the 45. So in the case of the 15, it needed a 3 so that I can go 3 times 15 is 45. In the case of the 9, I needed the 5 so that 9 times 5 was 45. So keep that in mind as we progress to the addition here. I know now that my common denominator is all of this. So this guy here is the equivalent of x plus 4 and x plus 1. This guy here is the equivalent of 3 times x plus 1. So I need to multiply the expressions by the remaining factors. In other words, the common denominator is 3, x plus 1, and x plus 4. Since this one already has the x plus 4, it already has the x plus 1, it's only missing the 3. So I'm going to multiply by 3 over 3. And then that's the common denominator. Okay? Over here, I already have a 3. I already have an x plus 1, but I'm missing the x plus 4. So I multiply by x plus 4 over x plus 4. Okay? And so now I have the same common denominator for both fractions, which is what I'm using over here. And my last thing is to multiply the top. So I'm going to go 3 times 1 is 3. And then because this is addition, and then I'm going to go 5x times x plus 4. And then I can simplify my expression. So at this point, 5x times x is 5x squared plus 20x, because 5x times 4 is 20x. So at the end of the day, I have in standard form 5x squared plus 20x plus 3 divided by 3 times x plus 1 times x plus 4. Alrighty? So that is how you simplify the expression. Alrighty? So now I'm going to ask you guys to do one on your own. Simplify these two expressions, or sorry, simplify this one expression. You want to add those two together. And then we're going to try one with subtraction, but again, it's going to be the exact same setup, only now instead of adding, we're going to be subtracting. So we want to start again with the least common multiple. So I will take the 5y squared minus 125, and that will factor because they both have a 5 in common, so the 5 will come out, and I will get y squared minus 25, and this is a difference of 2 squares, so that we would further factor out to 5y minus 5, and then y plus 5. That is the complete factorization of the first denominator. The second denominator is 3y plus 15. And they both have a 3 in common, so the 3 will come out, and you will get y plus 5. All right, so you can see that it's actually pretty important that you have really good factoring skills. So the common denominator for this function will be to have a 3 and a 5, and a y minus 5, and a y plus 5. Again, in this case, there are no repeated factors, so no need for us to put squared up there. So then that's your common denominator. And now I need to multiply this guy by what it's missing. So you remember that this has been replaced with 5 times y minus 5 times y plus 5. And this guy has been replaced with 3 times y plus 5. So we are going to be multiplying by whatever it is missing. So in the case of the first fraction, it's missing a 3. So times 3 times 3. And now it has everything it needs. This guy already has a 3. It's missing a 5. It already has a y plus 5, so it's missing the y minus 5. And there you go. So now the common denominator is all the same. So now we go to the top. 3 times 7 is 21y. And then we have a minus here. And this is 4 times 5, so it's minus 20 times y minus 5. All right, and now we're just going to simplify. So we're going to have 21y, negative 20y, because negative 20 times y is negative 20y. And then we have a plus 20 times 5, which is 100. All right, so we can combine 21y minus 20y is just 1y. So now we have y plus 100 on the top. And on the bottom, 3 times 5 is 15 times y minus 5, y plus 5. And this is the simplified result of the subtraction that we have there. Awesome. So now, again, you can try these two examples on your own. And again, for my buddy Ben, that is not 3bx, it is 36x. This is 6x, that's b, that's a 6, and that's a negative 6. So just to clarify. All right. This is our last example, our last thing that we want to learn, and this is what we call a complex fraction. And probably because it looks complex, it looks complicated. Basically, a complex fraction is when you have a fraction in the numerator and a fraction in the denominator, or both, or one or the other. In other words, you already have this fraction here. So this is your numerator, this is your denominator. And in the numerator, there's another fraction. And in the denominator is another fraction. So it's kind of like you've got a fraction within a fraction within a fraction. It's just craziness. So we call it a complex fraction. And there are a couple ways to simplify this. There's actually 2 methods. And I'm going to go ahead and show you both methods, and then you can choose which method you want to try to do. The first method is to look at the fraction of the numerator, and you can see that the denominator there is an x, and look at the fraction that's in the denominator, and that is a y. And then you want to do the same thing we've been doing, which is find the least common multiple. In this case, that would be easy to do. The least common multiple would be x times y, because x is already factored and y is already factored, so it's just, to find the common denominator, you have to multiply the two by each other. So you get x times y. And so then what you do with the least common multiple is you basically take the expression on top, which is the 1 over x plus 3, and multiply it by the xy. You're multiplying it by the least common multiple. And then you're going to divide, and then you have this expression, which is the 5 over y plus 4, and you multiply that by the least common multiple. And the purpose of that is to try to get things to cancel. So what's going to happen is, when I distribute the x times y to the 1 over x, I'm going to get xy over x plus 3xy. Because this is xy times 1 over x, and what's going to happen is that the x's are going to cancel, and you're going to get y plus 3xy. In the case of xy times 3, nothing cancels, so you just get 3xy. So I'm going to have this expression divided by, and the same thing's going to happen here. I'm going to get 5xy over y. So when I multiply the 5 times the xy, I'm going to get 5xy over y, and then plus 4xy. So the y's will cancel this time, and you will get 5x plus 4xy. All right? So now you can, and now that you don't have a fraction and a fraction, you only have one fraction, so now you can actually write y plus 3xy divided by 5x plus 4xy. Alrighty? And that's how you can simplify that little guy. So I want it to be the other way. So that's one way of doing it. So I'm going to erase this now. So if you want to pause, rewind, whatever. I don't have, space over there. So I am going to erase this method now. That is the first method of doing this. I don't know if that was your preferred method. It's actually not my preferred method, but that's okay. What I'm going to do is I like to deal with each thing on its own. So I would just take the numerator, 1 over x plus 3, and the 5 over y plus 4, and then I try to find a common denominator. So in this case, in order to get a common denominator, I'm going to have to do times x over x so that I can get a common denominator. And so this expression will be 1 plus 3x all over x. And over here, I do the same thing, so I'm going to times it by y over y. And that's going to be 5 plus 4y over y, like that. And so then, what I do next is I use this division. So we still have this divided by that. So if you remember correctly, when you divide, you flip it over and multiply. So I'm going to get 1 plus 3x divided by x, and then I'm going to multiply instead of divide. And when I flip it over, I'm going to get a y on this on the top, and I'm going to get 5 plus 4y on the bottom. So I'm flipping this one over. And then if I distribute the y to that and distribute the x to that, you get the same thing. 1 times y is y. 3x times y is 3xy. On the bottom, x times 5 is 5x. And x times 4y is 4xy. So you get the exact same answer. And to me, it just seems like it's a little bit less work. But again, you can try either method that you want. So you can try these guys here. And then we will see you in class, next class period. So muchas gracias for watching.
Gracias por venir.